Good morning. In this lecture video, I'm going to explain logic gates. So these are the components of digital circuits. As you know, the components of analog circuits are resistors, capacitor, inductors. So logic gates are the components of digital circuit. So I'm going to explain what are the logic gates available uh, and what is the operation of logic gates in this video. So logic gates, they are the basic building block of digital circuit which accepts binary input and produces a binary output. That means it receives either 0 or 1 or and it produces either 0 or 1. Okay. So you and these logic gates are used to create a digital circuit, a simple digital circuit or even complex integrated circuit. So that means IC, integrated circuit. Okay. So combination of logic gates forms a circuit and that circuit is designed with a specific task. Okay. So as example, adders, okay, to add binary numbers and flip-flops to set or reset the memory element. So complex integrated circuits are the complete circuit ready to perform several functions. So as you know, these are the simple circuit. Adders and flip-flops are the simple circuit. So one complex integrated circuit means it has complete circuit ready to perform several functions like now microprocessor and microcontroller. They are the digital circuits, digital circuit. So specifically we call uh, sequential circuit, complex sequential circuit. So again they enter designed with the logic gates. Okay. So there are three categories of logic gates. They are basic gates. Okay, one category is basic gate, not, or, and second gate is derived gates. Derived gates in the sense these gates are derived from the basic gates. So they are XOR and XNOR, exclusive OR and exclusive NOR. And one more category, universal gates. This is also comes under derived gates, but specifically we call them as universal gates because using these gates other gates can be realized. All this I'm going to explain in this video. So first we'll see NOT gate. What is NOT gate? Again it is an electronic circuit. So this is the symbol of NOT gate. Okay, one buffer and output bubble. Okay, X is the input, Y is the output. Okay, so it is an electronic circuit having only one input and only one output. In turn again these logic gates also made up of the passive components like transistors. Okay, so we call it as an electronic circuit. Logic itself is a electronic circuit available in the IC, integrated circuit. So having only one input and one output. Okay, output signal is always opposite to input signal, that is complement. So let's see the truth table. Input is X, output is Y. When input is 0, output is 1. If input is 1, output is a 0. This is the function table or truth table of NOT gate. So let's verify. So this is the Boolean complement. This is the Boolean complement operation. That is if it is 0, 1, if it is 1, or 0. That means, so it is similar, no? Okay. Truth table of NOT gate is similar to function table of Boolean complement. So we say NOT gate physically realizes a Boolean complement. So it is a physical realization of Boolean complement operation. So it is a, so definition of NOT gate is an electronic circuit having only one input and one output. Output is always opposite to input and it is a physical realization of Boolean complement. Okay. And it is also called as inverter. Inverts the input. So this is the expression y is equal to x bar complement. Okay. And this is an IC. As I said, gates are available in the IC. So within this IC again electronic circuit is there which implements NOT gate operation. So in single IC we have a 6 gates. Okay. The IC number is 7404. Clear now? And NOT gate using a switch. So how do we implement using switch NOT operation? How do we implement NOT operation using a switch? Let's see. This is the voltage source and this is the bulb. Okay. So we connect voltage source to the bulb. if we use in between one switch. Okay, so switch A. So if it is open, so let's write a function table. A is a switch, L is the lamp. If it is open means low, I means 0. Okay, if it is open, okay, what happens? Current flow in the outer path. Current flows in the outer path. So L bulb will glow. Bulb will glow. I. So A is 0. A is 0. L is 1. And if A is closed, okay, what happens? This voltage will flow within this loop. Okay. So current will not flow to the bulb. So bulb will be off. Lamp will be off. Okay. So if A is 1, L is a 0. So this is implementation of NOT gate using a simple switch. Okay, A switch is a input. Lamp is an output. If it is closed, it is off. If it is open, it is on. Right? So next we'll consider OR gate. Again, it is a electronic circuit having two or more inputs. In a NOT gate, only one input, one output, but OR gate has two or more. It can be 2, 3, 4, anything, and only one output. Okay, so it is a symbol of two input OR gate. Let's say this is output Y. A is and the input, Y is the output. And output Y is equal to 0 when all the inputs are 0. When all the inputs to OR gate is 0, output is 0. Otherwise it is 1. Otherwise it is 1. So that means if any one input is 1, output is 1. If all the inputs are 0, output is 0. Let's write the truth table. So A and B are the inputs, Y is the output. So these are the possible combination. See, first combination, all are, both inputs are 0, 0. So output is 0. The remaining, at least one input is 1. In the last combination, both are 1, 1. So output is all 1. Okay. And this is the truth table of OR gate. And let's see function of Boolean addition. Now this is the Boolean addition, correct? So 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 1. I mean true plus true, 1, correct? So compare the truth table of OR gate. It is similar. It is similar. So we call it is a physical realization of Boolean addition. OR gate realizes the Boolean addition. So the expression is A Y is equal to output expression Y is equal to A plus B, and this is an IC 7432 is an IC. It's having 4 OR gate, 2 input OR gate. Similarly, using a switch, how do we realize OR gate using a switch? So here two inputs, no, two inputs are supposed to be two switches. So we'll consider the same voltage source and lamp, and two switches are connected parallelly in between voltage source and lamp. Okay, two switches equivalent to inputs. Right now, let's write a function table. Right. So if both are A and B both are open means 0. Output is 0. Right. If both are open, current will not flow. Current will not flow. Right. So lamp is off. So both are 0. Output is 0. And if any one is closed, I mean let's say A is open, B is closed. So A is open, B closed. So current will flow in this path. So bulb will glow. It is on. Right. Suppose A is closed, B is open. Right. A is closed. Observe the diagram. B is open. So still current flow in the other direction. So lamp is on. If both are closed, current flows in both the direction. So again lamp is on. So that is the realization of OR gate using a switch. Okay. So as you know, output Y is equal to 0 when all the inputs are 0. Otherwise it is 1. Let's consider 3 input symbol. This is the 3 input OR gate. Okay, inputs are A, B, C, output is Y. Right? And this is the truth table. Observe the first combination. All the inputs are 0, output is 0. The remaining combination, at least one input is 1, so all outputs are 1, 1. Okay. So the expression of 3 input OR gate is A plus B plus C. Okay. And now we'll see AND gate. AND gate. Again, it is a electronic circuit having two or more inputs and only one output. And out, this is the two input symbol AND gate. A and B are the inputs, Y is the output. Okay, and here output Y is equal to 1 when all the inputs are 1. Otherwise, it is 0. So let's say the truth table. A and B are the inputs, Y is the output, and these are the possible combination. Okay. So in the last combination, all are 1. Output is 1. The remaining 0. The remaining 0 means at least one input is 0, output is 0. If both the input are 0, 0. If at least one input is 0, output is 0. When all the inputs are 1, output is 1. So let's see the Boolean multiplication. This is the operation. Okay. Here also, if both are 1, 1. Otherwise 0. Correct. So if we compare with the output of AND gate, so we can say AND gate realizes Boolean multiplication. So it is a physical realization of Boolean multiplication. Okay. Hence the expression Y is equal to A into B. And this is the gate 7408 is the IC number. So this is about two input AND gate. Again, we'll see how do we realize this AND gate operation using the switches. Again, consider the same voltage source and lamp. So instead of in OR gate we connected parallelly, we connect two switches in series, cascading. So let's see the operation. A and B are the switches. If both are open, okay, current will not flow. So lamp is off. Okay, yeah. Now if any one is closed, let's say A is open, B is closed. Still there is no closed path, there is no closed loop to flow the current. So lamp is off. And then if A is closed, B is open. Okay, still there is no closed path, current will not flow. So again off. So when both are closed, so there exists a closed path. So current will flow. Then it will be on. So if both are closed, I mean both are 1 1, output is 1. If any one is 0, output is a 0. Clear now? Fine. So now this is the function of AND gate. Let's consider three input symbol. So this is the three input symbol. Okay, and this is the function table. Observe the last row, all are 1, output is 1. In the remaining combination, at least one input is 0, so output is a 0. And this is the expression, Y is equal to A into B into C. Clear now? Yeah. See this diagram. So first one implements three input AND gate, output is ABC. So if you don't have three input AND gate, we can implement this either first we connect A and B as input to one two input AND gate, and its output is connected to input of one AND gate, I mean two input AND gate, other input is C. So A into B first and then multiply C. Otherwise, first we do A and B and that is multiplied with the A. Okay, this is how we can realize. Clear na? So other exclusive gate I'll explain in the next video. Thank you.